this gonna work this time? Hello, hello, hello. Is this gonna work this time? Yeah, sure, that's fine. Okay, wow, this has been a long time since I did this. Um, I have been doing work on my games, and quite frankly, I wanted to do this. So, I'll start with the normal stuff. I'm going to do a Greek lesson, but I've forgotten everything, so let's see how bad this goes.
Pa. Pa.
Ba for pie, I see. Select the matching pairs. Snore,
Snor.
snore, Oz,
Os.
Oz, na,
Na.
na, pa,
Pa.
pa, me, me. Select the correct characters for pa, pa.
Pa.
Select the matching pairs. Mare,
Me.
mare, na,
Na.
na, snow, snow,
Snow.
da,
Da.
da, an. Select the correct characters for da,
Da.
da. Uh, yeah,
Pa.
great.
Pa. Pa.
Pa,
Da.
okay. Va, va is,
Da.
uh,
Ta.
that?
Tha.
Oh,
Tha.
tha, okay, theta, I see. Okay, it
Da.
was da.
Da.
Va,
Da. 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 Είναι ο Δαβίδ. Είναι.
είναι,
Είναι ο Δαβίδ.
είναι βοβή,
Είναι ο Δαβίδ.
είναι βοβίv,
Είναι ο Δαβίδ. Ο Δαβίδ.
vaviv,
Είναι ο Δαβίδ.
είναι ο vaviv,
Είναι ο Δαβίδ.
είναι ο vaviv. Okay, I got it now.
Δαβίδ.
Um, yeah, sure. Verb because it's delta again, I see. So it's going to be είναι is, it's, I think.
Είναι.
Yep, it's, uh, vaviv, David.
Δαβίδ το νερό.
David,
Δαβίδ
to,
το
nero.
νερό.
David is water, or the water.
Γεια σου, Καναδά.
Yasu, Canada, Canava,
Γεια σου, Καναδά.
Canava, Canada. I don't know if it's pronouncing the D or not, but interesting. So it's going to be
Γεια σου, Καναδά.
Yasu is, I don't know.
Γεια
Hello,
σου.
hello, Canada.
Γεια σου, Δαβίδ.
Yasu, Yasu.
Γεια σου, Δαβίδ.
I don't know if.
Γεια
Okay, I didn't know that one.
σου,
Su, Vavid,
Δαβίδ.
Vavid, Vavid. Such a interesting way of saying it.
Γεια σου, Δαβίδ.
Yeah, su, Vavid. Okay.
Δράμα στο σινεμά.
Drama sto cinema. Drama sto in the cinema.
Δράμα στο μίνι μάρκετ. Δράμα στο
Mini
μίνι μάρκετ.
market.
Δράμα στο μουσείο.
Drama in the museum. Museo.
Δα.
Va. That's
Θα. Σα. Δα.
that one. Alright, cool. I didn't mean to do that. Damn it. Oh well. Cool. Okay, so that's over and done with. I decided that I would go back to actually implementing some of the project that I want to work on. So I think I should recap it even for myself. I have been working on these things, but I kind of lost the way. I was learning a bit of mathematics, learning a bit of physics. It was getting a little too much for me. Then I started to code some kind of programs in Python and all these bits and bobs, and even went to electronics, so trying to build little circuit boards and stuff, but only at a very basic level, so silly level. And I think I've got to the point where I'd like to now reset my mind into what it is that I want to do. So um, here we go. And actually, let me just check the resolution here because yeah, you can't see too much in terms of little the Visual Studio stuff, but I think it should be okay anyway. So the big old goal is a little bit like what AlphaFold has done with taking known proteins. That's actual experiments and processes that they've done to measure the shape of proteins have been recorded in a database called the Protein Data Bank, I think. And they have taken, God, I've got to remind myself. I suppose they've taken elements and applied physical constraints to them to see, or maybe something like DNA sequence uh, creates elements that then apply forces to each other and then make proteins fold in a certain way so that the the DNA leads to electrons and all these things, sorry, atoms. The atoms have forces, the atoms are things, so they create the protein. The protein then folds because of all the forces. And there's too many calculations on the forces for all elements of a protein. So what they've done is used AI to predict in various different matches from the protein database, so the actual database that has real material. They've said, well, in this case it was like that, in this case it was like that, in this case it was like that. So then when you put your own version of the DNA sequence or whatever it is they're working with into their training data set, it says, well, AI goes, well, I think it should be probably looking a bit like this, given all the other bits of training data that we've had. Very rough sketch of what they're doing. In a way, I'm doing that first. I'm doing that first because I need to understand the physics at play, and obviously we're talking quantum mechanics and all the bits and bobs there. This is all stuff I'm having to learn. Then you've got the chemistry, so understanding the elements and how they fit together and the open bonds and covalence and goodness knows what else. Uh, After that, I would like to be able to create a piece of software that simulates this. So essentially this has all been done before. I'm going to have to learn it. Once I've learned it all and I've got this simulation tool, I can start to put in chemical, uh, DNA sequences that lead to um, elements being created or operations that occur because the DNA sequence then create elements, not sure which, and those elements then um, create the proteins. And so what I want my software to do is you'd be able to say, okay, I want this DNA sequence, and then it would output this protein. And then I could say, okay, this collection of proteins that are made, I will label this, and this set of proteins I'll label that. And then I'd make a framework that says, okay, I want to create, I don't know, a specific biological uh, thing, and then to do that I can use all the framework that I've built up from the understanding of all the proteins and how they function. So it's a massive project, obviously, and never been done before, of course. So just trying to set the expectations very high, or the um, yeah, that'll do. I can't remember the words. I can't speak properly. Anyway, so once I've done the simulation, then I'm going to have this kind of tool that maybe a bit like a 3D printer, but more biological. So you're you're having to put the kind of basic, you know, um, biological components down, but hopefully to make some kind of like cell. Hopefully, it'll make a cell, and that cell will then have all the information to start its process of splitting and dividing, and thus you're going to have something build out and create itself. So it's a bit like a 3D printer, but like a biological 3D printer. Um, in which case, how much can I control that? So can I make cells that create, I don't know, a table, or pen and paper, or connect a spine, or um, give biological buffers to us so that when we go, the planet gets destroyed by a meteorite and we're up in the solar system, in interstellar space, we can go land on planets and modify our DNA or create babies with that new DNA that's buffered against it. And in no way, shape, or form do I mean I want to do anything, to improve our DNA per se. Although, protecting against diseases when you have them is always a good thing. And obviously, doing research into, well, can we prevent these types of diseases and have very little side impact? So it's a big thing, um, and I've got to start somewhere. So I'm gonna. This isn't a very wasn't a very good picture, but I'm gonna keep this open, and I'm gonna return back to some code I wrote a while back, which is written in Unreal Engine. And I think what I'd like to do is just start as a developer kind of thing, because that's my go-to. Um, I want to build up some unit tests, and um, I've already got some things that are called actors in this case. You've got the atom, and the atom is made of a nucleus, and the atom has an array of shells. Um, okay, so then we go to the shell, and the shell uh, has an array of electrons on it, and an electron is a core piece. It's like one of the fundamental things that we have diagnosed as scientists. Okay, so that's why it's got nothing else on it. Let's go back to the shell. That was all of that. So then we go back to the atom. So then the atom is made up of a nucleus, and if I go through to the nucleus is made up of an array of neutrons and an array of protons. Let's go through to the proton first, and the proton is made up of down quarks and up quarks. I think that should be the smallest component that we know of, which is the down quark there. And we've got the array of up quarks, and the up quark. See, this doesn't seem right. It has a shell, uh, so I'll have to think of why I've done that. And then the down quarks is a smallest component. It's probably a mistake, maybe. Um, and then we have a thing called an element. So an element is going to have electrons, which has protons and neutrons, all that kind of thing. And then a protein is going to have an array of elements, right? Because a protein is made up of many elements. So that's very basic structures. And I think first things first is to get these things to appear on the screen, basically. So I think maybe there's quite a lot of stuff here, and maybe this doesn't even run. So let's just now get into running it. So I'm gonna do my first build since goodness knows when. Okay, and there's errors, and it says there's a syntax error, and that's because a shell actor is an undeclared identifier, and that's correct because I haven't actually included it here. But the up quark actor, why does it need a shell? So now we can get into it. Let's go to Firefox, which is my learning browser. I'll try and make things nice and big. I'm going to go up quarks in Proton. Protons contain 2 up quarks, so let's go. Let's go to our proton. There's an array of up quarks, cool. And I can see all these clicks I've done already. And it says atoms are constructed of 2 types of elementary particles, electrons and quarks. Electrons occupy space that surrounds an atom's nucleus. Each electron has an electrical charge of -1. Quarks make up protons and neutrons, which in turn make up an atom's nucleus. So the nucleus, which I think I've got here, is made up of neutrons and protons. Great, okay. Each proton and each neutron contains 3 quarks. A quark is a fast-moving point of energy. There are several varieties of quarks. Protons and neutrons are composed of 2 types, up quarks and down quarks. Each up quark has a charge of +2/3. Each down quark has a charge of -1/3. The sum of the charges of quarks that make up a nuclear particle determines its electrical charge. Protons contain 2 up quarks and 1 down quark. Neutrons contain 1 up quark and 2 down quarks. The nucleus is held together by the strong nuclear force, which is one of 4 fundamental forces. Gravity and electromagnetism are 2 others. The strong force counteracts the tendency of the positively charged protons to repel each other. It also holds together the quarks that make up the protons and neutrons. In addition to electrons and quarks, physicists have identified a number of... Right, I remember why I did this now, and already I can see it's not very clear. So I think I've gone inside the up quark and I found this shell actor, and I think this is to denote what it's being shared with, like what is currently being interacted with it. So I think for now I'm going to delete that. Right. So we have all these actors, and then we have this controller, and it's got a load protein data. Let's see what that does. Load data from data table, and then we've got protein data, which is an element name, a symbol, and amount of protons, rather than calling it atomic number, but they are synonymous. Right, I see, okay. So here it looks like we've got some data structure already, and I guess let's just look at that. So if I go to my content, data, so it looks like it may be inside the editor itself. So okay, fine. So step 1, that's all looking good. Step 2 is that I need to change some of these over because this is Unreal Engine 5.1. Let's just make sure of that. Yep. Some changes have been made to how things work, and also I discovered that if you class this, it means you don't have to include these like the actual files themselves, and so when compiling it's a little bit quicker. So I can do something like that and save on some of the compilation, but the problem is then the CPB file would need to be updated, but luckily I haven't got that far yet. So let's go through these and update them here. And there is another change as well I have to make. Oops. I think even, well, maybe the structs needs to be done a little bit different. So although this says it's a class, so actually that probably is going to be okay like that. F protein data. No, it is a struct. It is a struct. It's funny how that okay, that seems to be working now. So if I call that a struct there, maybe I also don't need to include that. And furthermore, what is this? A protein. So maybe we're not quite close enough for proteins yet. And I feel like maybe I can just go ahead and delete that. So what I've come to terms with is um, switch between solutions and available views. Let me click that. Yeah, if I go to folder view, I can now actually just um, operate like a normal being without the filters that Visual Studio works with. So I think what I'm going to do is actually just remove the protein. Um, just not ready for it yet. So let's do that. Protein, by the way. And then I actually don't think we're ready for protein data either. We're going to keep it for now. Main pawn um, and data table loading service. Okay, well maybe we'll keep this. That's not so disturbing or distracting for me. I think that's looking good. So let's go ahead and make classes of this as well. Now I can't do that because in this case because it's a template I need to specify in the header, and so I want to make sure that I have the full type available to me to use. So let's not do that. But let's check here. There's a class of view input. Okay, that looks good. And some of these, I guess this is fine probably because well, let's see. Yes, because they're defined by the core code, I guess. And then controller, let me just make sure. So this could be changed. I just remove that and get rid of this. That should be good. So the second one is that these can't be defined as pointers anymore. So I think if I build this, it'll actually tell me, uh, that I shouldn't be doing it this way. So let's try that. Now apparently I need to switch back to this to be able to build the solution. That's a bit of a pain. Oh, and I noticed already that the protein is still there. So maybe we need to do a bit of this generating Visual Studio files. So let's do that. So show more options, generate Visual Studio project files, and that should hopefully reformat that solution. And hopefully that is now missing. Great, okay it is. So let's go ahead and build it again, and let's got some problems here. I need to actually put class here, and this looks fine. Let's see if there's any other silly mistakes I've made. Sure, as always, fatal, cannot open protein, that's correct. And I see, so it's coming through as protein data, but actually Okay, fine. Well, maybe let's just delete this, and we'll get to it. Or maybe we'll just comment it out. We'll get to it at a later date. In fact, let's comment that out, and let's also comment these out because it's of no use to me at the moment. Okay, now let's see. It says quite a few things. See if I can zoom this in a bit. I can't zoom this in, guys. I really apologise for that. Which is very strange. Maybe I can make everything a little bit bigger. 1 second. Font. Fonts and colours. Size 16 maybe. Okay. Ah, no, that's not quite what I wanted. Fonts. Let's go use defaults again. Maybe maybe DPI or scale. Let's see. Well, always helpful when you can't make this bigger. I really apologise. In fact, maybe just maybe I could put it in like Notepad or something. Maybe that's a bit more useful. Okay, cool. That is better actually. And let's try and take word wrap off. So it's saying that binary equals no operator found, which takes a right-hand operator of t pointer. So that's on the proton actor. So let's go to the proton actor. And it says binary equals no operator found that takes t that. No binary operator found that takes t that. With this is an error. So no operator found which takes a right-hand operator of t pointer, or there is no acceptable conversion. So it kind of looks like it's struggling with the T array. So let's now go to Unreal Engine, T array of pointers. Yeah, well, I thought that might be the case, but it does not seem to like that. Let's read this again. It says binary equals no operator found which takes a right-hand operand of type T star. And I just wonder if it doesn't need the star when I type it, but the in element type is going to have to be a pointer. Otherwise it would think it's a struct, right? Element type, here you go though. So this is already getting a pointer. So I wonder, let's go and have a look at Unreal Engine's documentation for T-array then. Unreal Engine T-array. Let's see, we want to go to 5.1. Let's see, any pointers? Well, T-array is the most common container class. It is fast element type. The element type is the type of the object that will be stored in the array, meaning all of its elements are strictly the same type. You cannot store elements of different types. The alligator is quite frequently omitted and will default to one which is appropriate for most. It defines how the objects are laid out in memory. It is a value type, meaning that it should be treated similar as any other built type, like int, It is not designed to be extended, and creating or destroying TRA instances with new and delete is not recommended practice. Um, this creates an empty array designed to hold a sequence of integers. The element type can be any value type that is copyable and destructible according to normal, like t-shape points and so on. No allocators may specify for t. So I'm doing something a bit silly here, I think. Um, now it may be that the difference is the fact that I've now used class. Uh, let's go see. I think there's a couple of upgrade things. Here we go. Using backward compatible include order. The latest version of UA has changed the order of includes, which may require code changes. The current setting is include older version include order version equals 50. Suppress this message by 51 in science editor target.cs. So let's do that first. There you go. Let's solve that problem. Then it says, alternatively, you can set this to latest, to always use the latest include version. So let's try that instead. This will potentially cause compiler errors when integrating new versions of. That's okay. Adaptive excluded from science atom determining max actions to execute in parallel. Yeah, let's give this another build and see how we get on. It's taken a while. Building 34 actions with 10 processes. Okay, what's the next one then? So it's recompiled all my CPP files. That's great. We still have the same problem. So I think next one is let's see what because I'm not sure I quite understand this. It says note could be with FD for a down quad. Let me go back here. It says could be T array of down quark actor or T array operator with F default allocator or default allocator T array T array of pointers Unreal Engine. I have this weird feeling that this is stemming from another thing that it needs in upgrading. So let's go to the upgrade guide. I think there is one somewhere. So let's go Unreal Engine upgrade guide, migration guide. That's the one. And it says steps and requirements for migrating your Unreal Engine 4 to Unreal Engine 5. Mandatory. The following section describes changes that you may need to make your where am I? To make your UE4 project in order to bring it into UE5. Um, yeah, here we go. So the following section only applies to projects using C++ code. Blueprints visual scripting users do not need to take any action. C++ licensee projects can keep using raw object pointers or optionally begin to use T object pointer. So UE5 introduces T object pointer, a template-based 64-bit pointer system, as an optional replacement for raw object pointers in editor builds. This system adds dynamic resolution and access tracking in editor builds, while performing identically to raw pointers in non-editor builds. T-object pointer variables also convert automatically to raw pointers when passed to functions or stored in local variables. So I guess it's something to do with this covering different build types, which is fine. That makes sense. I think like ARM processors, for example, don't keep track of pointer uh, um, quantities, but not so sure about that. Although it's optional, we recommend using T-object pointer over T-star for U-object pointers. So let's just do that as well, because I'm going to have to do it at some point. So I'm going to do a T-object pointer of that, which gets rid of that star anyway. Oh, I should have done that. Let's see, a T-object pointer, like that, and then let's see any more. T-object pointer of that, and a T-object pointer of that. Oof, where did that come from? And why is that not formatting it? Interesting. And then this one, okay, nearly there. What a pain. I suspect there's a automated workflow for this. I'm not sure it's big enough of a project to really care about that. Awesome. Okay, and then let's see anything else. I think that's probably actually. Ah, so I wonder what this does. So let's go and take a look at setup the player input component. Class A pawn. I guess we're looking for pawn.h. Let's see if it's there. I actually don't see it there. A pawn. Why is that not? Oh, here we go. Not sure what happened there. And so this is, yeah, okay. We're looking for that. So this is still a star pointer. So I think we'll keep that the same then. Maybe they haven't been able to upgrade it because of everyone's already using everything. So let's go ahead and build this. Right. That's almost a good thing because I suppose I would be confused if it was not liking the star. So that hang on a second. So there was actually some code in here. I didn't even notice the CPP part. Silly me. Okay. So how many of these have got actual code in? I think we actually also by default I think we should probably set these to false at this moment in time. And let's go back to that proton. And the proton is going to spawn certain quantities, but I don't think I'm ready for that yet. So yeah, let's remove that. And then to proton, then neutrons 1 up, 2 down, and then the proton is 2 up, 1 down. Okay, cool. Right, that's that problem solved. That was a silly problem. and we've succeeded on a build. So let's let's now um, let's now inspect what that protein data was, because I just don't remember. That was nice and fast, wasn't it? It says missing project settings. Shader model 6 is required to use virtual shadow maps. Please enable this in project settings, platforms, Windows, D3, D12 targeted shader formats. Open project settings. Targeted shader formats. Um, I think it. I'm not sure which one it wanted now. Because they do actually seem to be selected. Let me just leave that. It says, oh, shader model 6 is required. I see. Targeted and then 6. Okay. We'll restart later. So there's that, and then there's the actual thing. So what have we got here? Oh, we've got some blueprints. That's cool. So we've got a blueprint for protein, which I need to remove. Do we have everything? Electron, proton, no, electron. So we've got an element which has, we don't have an atom actor. Um, so I think, do we even have, we have an atom here. But an atom is kind of a bigger piece of the puzzle. It's not like really a thing. An atom is a collection of things, but the atom itself, I guess, can hold things together, right? So in a way, it does make sense to have one. So let's go and create um, an atom. Okay, and what's inside these? Is there anything interesting? Nothing yet. Okay, that's good. No surprises there. And then what's the controller? A protein controller. Ah, now that's interesting. No, and I'm a bit surprised because I don't think I see um, I don't think I see a protein controller here, so not sure why that's in there. And then so we had a game model base, science game model base. I think just probably comes with the engine, and then a main pawn, which maybe is just comes with the engine as well, and maybe it's just required to get the map started. So that's fine. Then you've got the data. Haha, here we go. So right, so here we go. We've actually got some data, and oh, it says amount of protons. So we're trying to build up a table of things like that. Okay, that's good. But maybe I don't really need that yet. So let's rethink that when we're ready. Uh, and that is part of the science game mode. Oh, I see. So we already really have started doing this. Protein data. Yeah, I'm not sure. I'm not sure I need protein data at the moment because I might rethink how this works. So I think what we'll do is we'll remove that from the um the game mode. I want to unravel, and then do things a little test driven. The scientific way, of course. Um, Game modes I'm looking for, but I can't see it. Where is the game mode? There it is. Okay, so we're going to remove that. Of course, I guess we can remove that. I think I'll also put that into its own mode. Let me think about this. So if I go, yes, let's do that. So if I just save everything in here, now it's looking pretty nice. And then if I go back to this other mode, uh, and I just delete this data here, and then I'm going to move this into a game modes. Game modes. Game modes. And then I'll plop that into the game modes folder. Yep. And then we'll put that into the CPP part. In terms of game, it's a bit confusing. I don't know if it really matters about its naming, but I think it comes from a game mode base, so it really depends what that is made from, which is fine. It's fine. So, and what is this file? This is for kind of inclusion stuff. All right, this is good. This is good so far. Um, let's do another build then. Like this. Ah, no, that was silly. So actually, instead, I want to generate this again. Which I wish I could pin this to the main. Can I do that? Like show more options instead, just like pin it. That should have recompiled this, and it has. That's good. Or generated it. Now I can hopefully rebuild this. Okay. So there's no such file or directory for this, and I suppose that's probably correct, because we need to go through the folder to get here. So let's go game modes, and then hopefully that's going to play ball. Yeah. Okay, right. So the next part then is to create these tests. Now I can't remember for the life of me how to do this, so I need to go to something that I actually made myself. Then we can kind of compare notes to see if it's still relevant to UE5 1. And it was show more UE testing. Here we go. So if I put that there, zoom in. So this says, what is this project? An Unreal Engine project running on 4.2.2, so it's a bit old. It's an example of how to implement the inversion of control pattern using Unreal Engine's type container. So if I click through to that, it actually takes me through to Unreal Engine. Cool, thank goodness. And this is actually Unreal Engine 5.1 documentation. Ah, yes it is, yeah, cool. So it still exists. And it says template for type containers. Type containers allow for configuring objects and their dependencies without actually creating these objects. They fulfill a role similar to class factories, but without being locked to a particular type of class. When passed into class constructors or methods, type containers can facilitate the inversion of control pattern. Since Unreal Engine neither uses runtime type information nor pre-processes plain old C++ classes, type names need to be exposed using the expose tname of macro in order to make them registerable with type containers, i.e. expose tname of that. Once a type is registered with a container, instances of that type can be retrieved from it. There are currently 3 lifetime scopes available for instance creation. Unique instance per process, singleton, thread, or factory. See the file typecontainer.cpp for detailed examples. Okay, well that's good, isn't it? So let's go back to my example because I think I may have done that already. Other examples can be found here. Yes, so I think though, let's go to the 5.1 and let's see if that's still a file. It is, great. So if with dev automation tests, and it's got this big old file and then endif. So we need to then know what this macro does. To be careful here, I want to go here. Now see, that's not actually coming up with what I've searched for, so that's a bit of a red herring there. Let's put that in quotes. To add the if macro before the function definition. Now this is interesting. Someone else has written a guide here, it looks like. Learning Unreal Engine, Ibbles. Okay. Let's see. Each chapter except for this one and the summary correspond to a source. Each source has a URL, an author, and optionally an Unreal Engine version. Tests can be in both C++ and Blueprint. This discussion is about C++. C++ tests should be in their own module or plugin. They should be in the private tests subdirectory of the module's source directory. They should be in this private tests subdirectory of the module's source directory. Now let's go and confirm that because hopefully that's where this is. Private directory tests, private tests in their own module. I see. Okay, so then let's go back to my example here. Skip to the how does it work section as it's more an overview rather than I need to look at everything. The game part of it, the UIOC is declared in a common file that is included in all files that need access to the IOC container. So I think I've done this wrong. Yes, I think so. I think what this is saying is you can do it here. So since UE neither uses runtime type information or preprocessed plain old C++ classes, type names need to be exposed using the exposed tname of macro in order to make them registerable with type containers. Registers a class for instances of the specified class, but I wonder where this actually exists. So t-type container, add an instance provider to the container. Let's look for that then. I think we'll just duplicate this tab. We'll do a little search. Analysis service. Yes, this looks good. No. Here we go. So add a provider, new test provider, and what does a test provider look like? Okay, that's not clear. So you have a factory, but I think I probably just want to register instances. In most cases, I think. Um, Gets a shared pointer to an instance of the specified class. So get instance. Okay, let's go back to this. So um, in the IOC, there's a container, and the IOC, let's see, its job in this project is to register interfaces to implementations. Its job in this project is to register interfaces to the implementations of a gameplay. So I've got to set up IOC registrations, and it's just registering classes here. Okay, okay. So the container is the type container, and register class is this. Okay. And then provides an example for how we resolve instances from the IOC container. Okay. Let's go back here. Okay. So we've got the player service is coming from get instance of iPlay service. Okay, that's good. And then it says take hit -1. Okay. And I've got an iPlayer, the interface which we register, player service, and other implementing implementations. So in this case, used for IOC registrations. Expose tname of. Aha, I see. Okay. Now we're getting somewhere. So it comes as a struct. That's interesting. Okay. Check out the expose tname of, which is required by the register class, which is on the type container. It is used to create a simple struct that allows internals of type container to reference your interface by name. Check it out on the Unreal type traits.h file. There it is. Okay. Player service is an implementation of the iService. Okay, let's see how that works. So it just inherits from the struct. Um, okay. Mm, so probably I don't know if that's a perfect idea. Because C++ doesn't have interfaces, so we're actually using inheritance here. But let's go back to that class of iPlayer service, that struct, and it's actually it. Yeah, okay. So it's a required thing. Okay, well that makes some sense then. And then player pawn test. So uh, player pawn serves as a container to help with code maintenance and tests. See below class for actual test entry point. So we've got a mock player service. Okay, and we've got the constructor for this is making a mock player service. Okay. It's registering an instance of iPlayer service to the mock instead. Instantiate the mock objects used in the test. So new object, and then enemy doesn't lose life when player power modifier is less than enemy power. Um, yeah, so these are the tests, and automation test base is coming from F automation test base, okay. And then this is this is the running of the test and then execute the test. What's this? Implement simple automation test. Okay, so this is like the helper for it, and then okay. So just trying to think, have I got some pull requests here? No. And no issues. Okay, that's good. So I think we've got the whole lot there. So now we need to do it. So the UIC is declared in a common.h file that is included in all files that need access to the IOC container. So let's do that. IOC.h, and it's in. So okay, so the project is called testing. So we've got this IOC.h file. Let's go ahead and do that. Folder view, and that's going to be in here, I guess. But actually, I don't I don't think I want it in here. I want to have it in its own module, as the other guy said. So now I need to make my own module. So let's go look at that. How to create new module in Unreal Engine. I have done this before, just no way I can remember. First, you need to set up directories to contain the module and its code. Navigate to your project's root directory, then open the source folder. Open the source folder, okay. Inside your project source folder, make a new folder called module. Okay, let's call this science tests. This will serve as your module's root folder. Inside your module's root directory, create two new folders called private and public. Private and public. Okay, we can do that. Private and public. Your directory structure should resemble this. It does, okay. Creating the build.cs file. Let's just go here. Yeah, okay. So let's double page this. And it says, when Unreal Engine build tool looks through your project's directories for dependencies, it ignores your IDE solution file and instead looks at the build.cs files in your source folder. Every module must have a build.cs file in your source folder. So here's your source folder, and here's those build.cs files. No. Here's the build.cs file. To set up your build.cs file, follow these steps. Create a file called in your module's root directory. So let's go here, new file. It's going to be science tests.build.cs. Every module must, yep. Open this file and add the following code. And this will be called science tests. Okay. This will make your module visible to the Unreal build system. Edit the constructor, edit the constructor so that it reads as follows. Okay. Let's go a little bit nicer, let's say. And then this will add the core UObject and engine modules as private dependencies for your module. This will take several classes available to this module for later steps in this guide. Now when you add code to this modules folder, that code will be discovered both when UBT builds the project and whenever you generate your IDE project files, implementing your module in C++. While the build.cs file makes your modules discoverable to UBT, your module also needs to be implemented as a C++ class so that the engine can load and unload it. Fortunately, Unreal Engine includes macros that can streamline this process for most common implementations. To make a quick implementation file, follow these steps. Navigate to your module's root directory, okay, and open the private folder, okay. Create a new file called add new file science tests module.cpp. It is not necessary to make a .h file for this class. Module name module is the typical naming convention for module information files. In Unreal Engine source code, this is useful keeping track of them in large code base. Inside module.c add the following code. It's going to be science tests. This provides a default implementation for your module that makes it available to C++ code. You can create more detailed implementations by manually writing the class for your module, its constructor, and the startup and shutdown functions for it. However, for most gameplay modules, this default implementation will be sufficient to load and unload your module. Compiling your module. After defining and implementing your module, the process to compile it is very simple. Right-click the U project and click Generate Visual Studio Files to regenerate your IDE. So let's do that. Anytime you reorganize your module's code or change the contents of its build.cs file, you should regenerate your IDE solution to make sure it stays up to date. Compile your project in Visual Studio, your new module will be compiled alongside it. So let's do that. There we go. I don't think you can see this, but I can definitely see that it hasn't compiled that. So I must have missed a step. Including your module in your project. Your module should be able to compile, but to use any code from your module in your project, you need to register it with your U project file, then make a dependency for your games project primary module. Open the My Project root directory, then open myproject.u project to this one here. Oops, forgot about that. See, because I've registered it to open like that. I'll have to drag it in instead. Let's do that. Ah. Let me think. Open with. Let's just go back to set as deep. Don't even know what the default is. Guess it's a source code text editor with encoding. I tell you what, let's find out what something else opens with. Common language default, okay. So let's try that. file cannot be opened with the selected editor. Please choose another editor. Um, okay. Right. Ah, so modules. Here we go. So it does say that, and it says just add it like that. Okay. Cool. So science tests runtime. Okay. You can use this list entry to configure which loading phase it will load up on and its type. This example is a runtime module, so it can be used when the project is running a standalone application or an editor. By comparison, editor modules can only run in the editor. It also uses the default loading phase, editor modules, editor. And I've changed that to editor because it's a unit test, right? So I don't know if it's required on runtime. Depending on the specifics of your module, you might need to use earlier loading phases to make sure other modules that depend on it don't throw errors looking for unloaded code. Navigate to your source folder, then open the build.cs file and add module test to your module names. So collapsing this up, it's going to be build.cs. Yep, here we go. And oof, don't like that. Get that on one line. Yeah. Let's add it to the public ones. Okay, so let's go ahead and add that. Now it'll be possible to include code from your module in your primary game module. Oh, I see. So I actually don't want to do that, do I? I want it to be the other way around. So actually, it might be more like if I take that back out and then go to this build, I suspect what I need to do is define this as science like that, because that in itself is a module, isn't it? So the there it is. Yes, okay, yeah. So now maybe this now has access to that. Let's see what adding code to your module. So let me just try and run that. Okay, doesn't seem to not like it. That's good. And I suppose if I now write something wrong in here, when I build it should fail, but it does not fail. So it is not building that yet. Let's do a reshake because I've just changed the build.cs like it's just told me. Okay. Nothing seems to have changed here. Let me try the build again. Okay, so we got a problem, which is it's not actually running anything at the moment. And in fact, if I do something there even, yeah. So now if I include that back in, does it start to build it? I wonder. Yes, I believe it does, yeah. Ah, now that's interesting. And so it's now compiled that, but we definitely don't want that. um, like this. So I think the test really is going to be if this has access to um, if this has access to the other stuff. Atom is it atom actor.h? So it doesn't like that. Um, and I'm guessing that is not gonna like that. Okay, so that's something's failed so far. Also, just need to remind myself of what this is again. T object pointer was that? Okay. Okay, so that's not working. We're nearly at the end, so let's finish this off and then we'll start Googling. It says you can add C++ files to the public and private directories in your module manually, or you can add them in Unreal Engine editor. These steps will guide you through using the new class wizard to add code to a module. Open your project in Unreal Engine, click Add New Class, choose Actor, locate the drop-down menu to the name. It should read My Project. Click this drop-down and change it to Module Test. If you do not see module runtime as an option, review the previous sections to ensure you follow the steps correctly. Name the class module actor base, set the class type to public. Your classes will open automatically in your IDE. Cool. Finally, follow the steps below to test your new actor class and your primary game module's ability to see it. Access game code from a module, Unreal Engine, I think is the next step then, isn't it? Ah, no, now I see. So the point of me adding it to the main module is so it can actually run it. It's not me just looking in. It has to be this way. Now I understand. This makes a lot more sense. So if I go back to my build.cs and I put that in, this does actually make sense. And if I go to this and remove this, this does make sense. Okay, that's good. Good. Okay. And then we've got some failures here whereby this is not quite right. But hey, you know what? I think if I now do a reshuffle of this, we will have more luck. I'm glad that made sense to me just then. The reason why you have to load it in as part of the games modules is that you're running the game and that's where you're going to run the tests, right? And I think there is actually an explorer in there too. So hopefully running that is going to work better with seeing this file. Otherwise this is not going to work. We can see T-object pointer now, which is good. This still doesn't like that. So here's another thought. Maybe not only do I have to do it that way, but I have to do it the other way as well. So let's try including this. That means I've just edited that, so I need to rebuild this. I'm not sure about this one. This one does make sense logically, but I doubt it'll work because now we've got some kind of circular dependency going on, but maybe it doesn't care. Guess we'll find out. So something has changed again, which is good. And let's see. Do you now have access to the actor? We do indeed. Okay. Good, we've made some progress. That's awesome. Um, It doesn't seem to think that this is it, but if I um, let's just try and run this and let's see what actually happens. Module entry science test specified an unrecognizable module loading phase editor. So next is the loading phase we've got to do. Um, so Unreal Engine module loading phases. Earliest possible, post configuration, pre-early loading screen, pre-default, default, post-default, post-engine initialization, none or max. So I'm guessing maybe it's just default loading phase because it doesn't have editor there, which is oh, here we go. As soon as possible. In other words, U plugin files are loadable from a pack file. Um, Loaded at the default loading point during startup, during engine initialization after game modules are loaded. Right after the default phase. Interesting. Let's just see if that works. I don't know if it will. Let's go and generate that again. I don't like the fact that this is taking a while to right click on that and generate it all the time. Okay, no changes that time. So let's hope for the best here. So we're in the engine. That's good. Um, if I go to Tools, New C++ Class, go Actor next. I do indeed see science tests. Okay, that's good. So I think the next one is like can we create a test like a unit test from here? I doubt so. Functional test. Um, I don't see anything. No. Okay, so the next step is to make our first test, um, and then we'll pick up on it in the editor. So I think we need an IOC, as this is doing. And in order to do that, I'm going to stop the engine. I'm going to switch over this again, and I'm going to put my IOC inside the main project, and that's because I want to. You see, now that's interesting. Do I really want to be having a static inversion of control, or do I want to new up a provider, like a service provider, right? Um, I guess they're the same thing, but the container itself is in this case static, and it means that I can never create another one. That might not matter. Um, that might not matter. Let me think here. So I think the point is that as the game runs, I have the game instance available to me, which is where I'll like make a new or make a reference to that container, right? So the T-type container will be inside the game instance, but if I follow my existing code um, in here, set up IOC registration. So that's going to run on the constructor of this. Yeah, in the constructor I run it. Then we start registering classes. Great. But then we have this static reference to the container rather than it be specific to that. But here's the problem. Here's the problem. If I don't make it static, then can I get access to a game instance without newing it up from my tests? And that would be important because I need to, at the testing phase, I need to. No, no, no. No, I don't need to do that. So the IOC container can be specific. So there might be. So I wonder how the T-type container is actually. Where is register class called in Epic Game Code, I wonder? Let's have a look. So they're registering classes in here, but not inside their actual game. You see, so I find that quite interesting. That they're only. So how are they resolving that in their actual code is the question, right? Now are they saying you it shouldn't need to are they saying that you can register well this is not obvious at all. So we're gonna make a banana, for example, and then they're saying that the iFruit is registered to that. So how have they used iFruit, right? A T-shared reference of iFruit. Right, I see. Okay. But how do they resolve that? Because they well no, see this is a problem because they're gonna uh delegate test. Get instance, container.get instance, and container is just some. So I suppose in a way it really does just need to be static. Uh, because it doesn't look like there's a way of passing that through into actors, right? So if an actor is here's an actor and it has its constructor, right? But the constructor has no immediate way of getting to that container. And we can double check that if I go through to the actor, I'm pretty sure I'm pretty sure the object initializer has no container on it. Um, we can do t-type container, right? T-type. There's actually quite a lot here, so let me just make sure of that. Yeah, no t-type container there. And then well, one was suppose that if I went back to the actor again, yeah, here, because static construct object parameters. I wonder if someone has got an example here, because this would be so good if I could understand how get instance is called from within the code. Let's, for example, just look at the wider audience here. Engine get instance, and it was t-type container, I think. T-type container code. Yeah, it's maybe a little too. You would imagine their Unreal Engine code has this used quite a lot, but like apparently not. Ah, now what's this? So yeah, actually this is a good point. It says template for type containers. Type containers allow for configuring objects and their dependencies without actually creating these objects. They fulfill a role similar to class factories, but without being locked to a particular type of class. When passed into class constructors or methods, type containers can facilitate the inversion of control. Since Unity neither uses runtime information nor preprocessed plain old C++, needs to be exposed using the expose name. Once a type is registered with a container, instances of that type can be retrieved from it. There are currently 3 lifetime. Yeah, this is the documentation, isn't it? See the container test for detailed examples of how to use each of the type registration methods. In the interest of fast performance, the object pointers returned by type containers are not thread safe by default. If you intend to use the same type container and share its objects from different threads, use thread safe instead, which will then manage and return thread safe versions of all object pointers. Note, type containers depend on variadic templates and are therefore not available on Xbox One at this time, which means they should only be used for desktop applications. That's fine. Um, so if it's passed into a constructor of something, so we're saying here that our services classes do have the ability to have constructors of, but do they? Because they need to still be U objects. Um, because otherwise we've got to manage them. um, I feel like instead I should. Oh, this isn't clear. This is not clear on what to do here. Maybe we should get going and find out where the flaws occur. Um, which in any case means I need to create the IOC. So let's go ahead and do that. And we'll start with maybe just put it in this main thing, a new file called IOC.h, or dependency inject di container is fine, isn't it? I think everyone knows what that is. And in fact, I've already done a mistake. Let's plop that into there. So with our di container, let's go pragma once, and it's going to be, well, let me remind myself of what a uObject service looks like. So bear with me, because I can never remember. Aha, here we go. Core minimal. Let's get that. And then we've got this stuff here. Let's just grab that, and we'll grab that. Let's call this di container, and we'll do this as science API. Get rid of that. And then I guess this is going to be a U property with a category of custom, and it's going to be a T-type container. And let's go back to our code again. Oh, I did have it there anyway. Oh, that's annoying. Well, whatever. This is static. So I think in a way static could work, because what it means is I don't have to keep going to the main instance to go get it. I don't think that's required. So let me just plop that in like that. Then again, I don't think static can be a U property. So maybe something like that is okay. And then inside, I tell you what, this is driving me nuts, because I think it's going to be quite a lengthy thing to keep calling. So maybe I should just call it di. And we'll put a note up here, I think, and we'll call this dependency di. Let's say its name. Well, yeah. Unreal Engine comment reader C++. Let's just see what they like. Well, I suppose they have done this, so let's oh, like that. Is that what they're doing? I'm just trying to copy what Unreal Engine are doing now. Let's see what they do. Yeah, they put it in those Java doc things. Oh no, this is me. Silly me. Um, okay, fair enough. So maybe it doesn't quite matter. Let me go back to this then. Um, I'll say something like. So I swear this is a. Because sorry, I'm just trying to understand something here. If I do void something string a, if I do that, then it doesn't have params, right? So does it even pick up on them? No, it does not. So it's pretty useless to use C++. Ah, now hang on though. That's a bit unfair. Let's try it here. Does it have params now? No, it does not. So I think that's a bit useless to use Microsoft's things here. I think I'm going to go for the kind of standard double forward slash. Okay, cool. Um, let's say that this class is name is di. Well, we can get that from there. Let's just put yeah, dependency injection container. Maybe we should call it dic. DIC. Let's call it dic. Yeah, I think that makes a lot of sense actually. Cool. And then we've got our container now, and this can be um, copied from here. So let's go to the game instance now. Well, actually, this common.h is including it, so let's go and do that now. And I think it's here. Interesting how core minimal is included everywhere anyway. Um, let's do this as dependency injection. Or maybe we should call this no, that's fine. Sorry, it doesn't. We don't need that. So okay, so we've got that. So why is this not finding it? That's because I spelled it wrong. And then that means that why does everything else have core minimal, even though it's already included here? I wonder. Um, that is not something I understand. Let me just go and check. If I go to player pawn, is that common.h is included at the top? I see. Um, right. So let's imagine that's been included. Then we go to the game instance, and this is going to have a constructor. Exactly, thank you, Copilot. And then if I go to the front end, it's going to be science game mode base is like that. And then in here, well, it seems to like that more, I guess. Let's just do that then. Ah, well, I'm not used to it. Then it's going to be dic. In this case, I'm going to need to include this here. And then dic uh, equals, no, dic, it's going to be pointers, so it's going to be t object pointer equals dependency injection. Dependency injection container equals that, yep. Now how do you make this make shareable? I think this is actually new object, I think rather. I mean, maybe make shareable has, it does, okay. But I think it's new object, to be honest. I think that's the one I want. Yeah. So now we've got this new object. I need to store this, and so the dependency injection container can sit on here as a public thing, and we'll call this custom, I think, again. It's going to be read visible anywhere. And it's going to be blueprint read only. Well, I don't really know why it needs to be blueprint at all, to be honest. In fact, maybe it just needs to be a category. Oh, I'm doing this wrong place, actually. As well, that doesn't help, does it? So it's not here that I want to do it. It's the game instance. Let's just plunk all that out there. Go to the game instance, which is, I see. So there isn't a game instance yet. So now I need to make one. Right, okay, so this makes sense. If I go back to this, let's go and make a game instance. I thought I'd had one, but clearly not. Output. Now this is expecting an include. An include at the top of the header that follows all other includes. I see. So expected an include at the top of the header. That's going to be include dot generated dot h. Okay. And this is going to be a u like that. Let's see. Unable to find class delegate. So it doesn't know what that is. Let me just take a backup of that. So can I define this like that for now? I wonder. Yeah, okay, so I don't think I can do that. And the reason is because it's this templating. So if I go back to my this, then I can just include it here, I guess. Well, well maybe also that I can include it in the main one, but let's see how this progresses. And I think I don't need that anymore. And this is unable to find class delegate enum or shop with name t-type container. Let's try and open this file. Oh, how do I do that again? Is it that? Nope. I thought it was Control Shift 12. F12, okay. It doesn't like that, so let's go to the documentation and let's see if we can find T-type container, the header file. And the header, I don't think it's changed, to be honest. Oh, here it is. Yes, it has changed. Aha, okay. Right, so that might be a bit better. So the next one is, can it not be a property? Interesting. So it cannot be a property, and that's why this can work as a static. Ooh, I really don't like that. So if I call this dependency injection container, I think that works even better now. Let me go back to the folder view. Call this di dependency injection container. And I'll need to reload my project. Reload. And let's see if we now compile. If I go back to here, let's see how we're doing. Error. Okay, that's fine. Expected and include. Yes, of course. And then can it include di? That's fine, like that. Great stuff. Okay, wow. Right. So now, if I go to the actual game, I will, or application, I will go and create a game instance. So tools, new class. So we can find it, game instance. Ah, so apparently I probably need to do it here then. This will be science game instance, and I shall put it in a folder. Like so. We're done. Okay. So now that's done, we can start to do that code I just started here, which I think will suffice. Something like that. I think that's an A, but it might be wrong. Yeah, it's a U. Okay, fair enough. And then that should be fine. So di should come from the main file, but it doesn't, which is a shame. So I guess you can't include that for everything, and it actually makes me wonder what this is even for. I don't know. Let's get rid of that. Let's put that in here. Hmm. It's interesting. Cannot deduce template arguments for t-object pointer. Undeclared identifier, even though it's here. Ah, UDI, that's the one. And actually that may have worked before then. So if I remove this again, so it's gone, but then if I put it up here, does it then start working, I wonder? No. It doesn't know what that is, so I think I have to go in every single file that I want to use it, which is fine actually, it's probably better. Um, yeah, okay. So then we have our dependency injection set up. We want to make this a local variable. And so I guess this is going to be a U property of UDI, and that would be a T object pointer. That could be a class, and this will be UDI. Sorry, DI. And let's just do this as a category. And so then I can just set that instead. Let's see how that goes. Okay, so there's some problems with that. And it's saying property has a category set, but is not exposed to the editor or blueprints with edit anywhere. Blueprint, editor or blueprint. So I need to do I need to remove the category maybe. Let's see if that does something. Sure, that's done it. Okay, good. Um, so now we have this dependency injection container set up. I suppose we can get access to the game instance, and it makes me wonder: was I sure about this? You know, so maybe I can actually do this. Let's just try that. No, that was a type problem. Okay, fine. And so it almost renders it a bit pointless to have it as a static method. Um, if it's on the game instance, but then yeah, as I said, I have to always resolve the game instance to resolve things, but maybe that's not such a big problem. Um, you know, I just worry that static, I don't know how its lifetime. Well, it doesn't even matter, does it? Because it's lifetime is okay. So that's fine. So we don't really need to register it on the game instance at all. In such a way. Um, yeah, that is actually not required at all. Uh, but of course I need to, instead on the game instance, I need to register. Um, I need to actually do. Um, it's going to be register instances on di container. Right. Can I? Yeah. Cool. And then in here, so this is pointless now. I would do UDI container dot register class instance. Register class. I think it's register class, I suppose at least. Let me just double check my thing again. Set up IOC registrations, yep. And then we're going to go here. Register class, okay, great. So register class of, and then I need something. So, to make this make sense, I think we need to have our first service in place. And that service it'll almost be a factory actually. It'll be an atom factory. Yes, I think an atom factory can be used by an atom repository. Um, Although yeah, let's call it a factory. So let's make a new folder called factories. And inside here, we're going to have an atom factory. An atom factory.h. And if I do, yeah, exactly that. U atom factory, U object. That's fine. I think I need a thing there. I'm not sure why that's like that. Yeah, I don't understand that. And then we'll put this up here as well. And then the factory will need to have a method that creates an atom. So exactly that, right? I don't think we need we don't do we need a constructor? No, I don't think we do, because it's a U object and it's already got one here. And create atom needs to be, you need to be able to define properties of that atom. And I suppose the best way to do that is just to provide an atom object, right? But that's the problem with the atom, is because I need to be restrictive over it. So something like we could say how many uh, how many how many n- nucleus has how many neutrons and protons? Um, neutron count, proton count, and then we're going to have, it's going to be a bit long actually, to be honest. And we're going to have electron count, sure. And actually, where is the electrons here? The shell has electrons. Fair enough. Well, okay, this is making sense why we need this sort of thing. Um, but it's actually going to be it's going to be a list of shells, isn't it? List of. So maybe this is not quite going to work. Um, in the way we think it should. I mean, maybe actually I should start with a shell factory. Uh, let's do that instead, I think. And then the shell can be create a shell with how many electrons, right? Um, though I guess it's not really that important about the shell because the shell is always automated um, in a way. It's like if you want this many electrons, then you're going to have this many shells. Um, I well, yeah, I think yeah. Let's put this back to Atom Factory. I think I've got something here. So Atom Factory, create an atom. So we're actually just going to go for the electron count right now. I think electron count, and then we'll have a. I think that's it actually. I think that'll totally do it. So let's go and glue this up. Uh, yeah, I think what we'll do is our game mode will spawn. No, we don't even need to do that. We just want to test this. So the module is here, but then we want to create the test. So let's go ahead and figure out how to do tests. So we have our player pawn tests is just a section of the player pawn test agent. Okay, and this is in source testing tests. So it's in tests. So let's do that. Um, tests, and then we're going to have gosh, a lot of stuff. let's just double check. Well, I mean, I can just do it, can't I? So let's go um, atom factory tests dot cpp, and let's one side by side this so I can just get this out quite quickly. We need to include the DI container, and is that available? It is. Great. Okay. Um, but I might not need that yet actually. But it's good to know. I also definitely need to do. No, I don't because I'm in the CPP file. So that means that there must be a header file here, right? No, there's not. That's interesting. Okay, cool. Right, so a test agent serves as a container to help with code maintenance in tests. See below class for actual test entry point. Let's just copy that. Well, so I'm getting a bit lost now. Class. Let's call this the um, Atom Factory Tests agent. It's going to have a reference to the automation base. And then that means I need to get the automation base, like so. And I want to do a constructor, and it takes the automation test base, and then I set a reference to that, I'm guessing. Let's see though. How precisely that's working, I'm not so sure, because it doesn't look like I even set that at all. Oh, I guess, yeah, that is a C++ thing, isn't it? So you set the value of it there. So let's actually instead, let's put that like that, and then we'll pass that into that, and that's better. And then we're going to create an instance of our a new. I don't think we need to make it shareable. You know, what does make shareable do? Oops. Let's go back here. Make shareable. Make shareable utility for wrap object pointers with the make shareable to allow them to be implicitly converted to shared pointers. This is useful in assignment operations or when returning a shared pointer from a function. I think maybe new is a T shared reference. I don't know if that's required. Um, let's stick with it. Let's see what happens. So U atom factory, and so we also need to include our factories atom factory, and then this will be this other part, which is the struct. So somewhere there's a struct declared for that. So if I go back and then go to services, aha! Yes, okay. So this could um That's interesting. Yes, I think I probably want to. I probably need to do that then. So if I go to interfaces, and then we'll call this. No, that's fine actually. I think if I just do that, and then I'll kind of copy that into there. Oh, apparently I can't do that. Copy, paste. Oh, it is doing it. Haha. Okay. And we'll call this the interface of iAtom Factory, and then that needs to be a struct of iAtom Factory, and just copy this basically. And uh, I think I can make this like so. Um, in fact, now I look at it, I think it's not quite as many as I thought. So maybe I should do that. No, I don't like it. Um, do I like that? No. Okay, cool. So now we've got the use for DI registrations. We'll do that. Um, does this needs to inherit from it? So this is a problem now because I think my player service may not inherit from. Yeah, this I don't think this works like that. Um, I don't think that works. We can find out though, I suppose. Uh, let's go see what Unreal Engine do. They may not know what to do themselves because it doesn't look like they've used this a lot, but they're only inheriting from this, and the rest is just structs. Uh, they're not like classes of declare return value. Wonder what that does. Static delegate return value. I need to be careful there. Um, that's not very helpful, is it? Single or unicast delegate type. Binding usage. Um, Trying to find some examples now. UE4 has several macros for defining delegates that are named as follows. For example, declare delegate return value declares a regular delegate with a return value. Now that we've declare the delegate type. We'll add one of these delegates to our class. Oh, is that how you get them? Oh, now that's interesting. So what it's saying is that you can say that you can use that to get it maybe. Simple automation test helpers tests per process test. Smoothies one.get. Make shareable, register factory, get instance. I think they still are getting instance, but it's interesting because um, smoothie factory delegate. Where is that actually used? Register delegate. They definitely are. Oh, I see. The delegate is creating the items for us. I don't think I need that because I'm just registering a class. So container.getInstance is still fine. Okay, sorry for the little side swing there. I'm getting a bit tired now. So now, we're creating these tests, and I want to create an but then we have the problem of the factory because it's on this, and I don't know if you're allowed to do that, and I don't think you can even build this at this point. So we'll keep an eye on that, and let's imagine this did work. Atom factory. Atom factory. Register atom factory to atom factory. Oh, you see, because that's interesting, because I'm registering an instance here, but um, so create static. What does create static do then? I see, so create static is part of the framework up here of it returning two parameters when you ask for it. Make smoothie. Oh, this is very complex to look at. It's like a lambda here. Make smoothies. Make smoothies is being called in a thread safe way to go and return smoothies, and then you've got the smoothies. The container, you've registered classes. So what does register class do then? Unique instance per process. So if I want to get an instance, I almost don't even need to do that here, do I? I don't need to register instances here. Oh, I do, because the code needs to know about it. So in this case, yes, I see. If if code used that factory, then that's why the IOC needs to be told to register that instance of your mock. Um, but to be frank, the class itself could have a constructor with instances. Uh, yes, I think an element has atoms. An element has an element is an atom. An element is an atom. Yeah, this is wrong. So this needs to be called a element actor. Or even better, just delete it and move this over. Yeah. So I've got a bit quiet because I'm trying to think now. A bit deeper than I would like to. uh, so I think though, let's just delete all this stuff because it's completely annoying me. It makes me think I needed it for some reason, which I actually don't yet, of course. I can always just add it back in when I need it. Okay, right, so instead of an atom actor, we're going to have just an element actor, which I think makes more sense. And this is going to be an element factory. And this, of course, would be an element factory. I need to do that for the private now. So electron atom actor is gone. And this will be just fine. Now, I think I need this factories folder in here. with a element factory.cpp. This will include factories element factory.h, and u element factory. Yeah, we don't need that anymore. Old school, dude. I actually don't need that at all. What am I doing? I need to do that instead. Yeah. Uh, Good, and then this will not be void. It'll return an element. Create element, and this will be a t object pointer of u element actor. And of course then I can go here and do that, and I can go and add my element actor. Okay, good. Uh, so that's done. So let's just return a u element actor, and then we can test that code, right? If everything's working. So we now have a test folder that is going to create an element factory which is also actually going to be called element factory. Here it is, element factory. Whew, element factory. I could have done a find and replace, but don't judge me. Okay, cool. This is useless. Create an instance of the new mock player server. So, I guess this really just does not a lot, because I just don't think I need it in this case. Let's go down to implementing this. Pawns.player pawn tests. So this is going to be element factory tests. This is a factories element factory tests. Editor context, engine filter, I'm not sure what they mean. And then this, it's interesting because where is that coming from now? So okay, so apparently it's just that, and I'm guessing that's not declared anywhere else, right? I think it's probably this thing that generates a class. With these in, yeah, I think because test. Let's see. No, because I'm declaring a new agent here. So this is just declaring a class for me. Is that what's happening? Let's have a look. Player pawn tests. Check out the instantiation of this inside its belly. I found it useful to organize my tests in this way. Recipe test simple. Okay, belly. Belly. Who said that? Yeah. Okay. Cool. So it does indeed. This obviously instantiates stuff for us. So then we're gonna have this, and we're passing this into it. this is the automation test base, okay, and then we're going to test that one of these works. And so it's going to instantiate, and therefore we're going to have an element factory. I see. We're going to register instances, but we actually don't need to do that. So let's just knock that off. And I think instead we'll just make. So what was this actually for? I don't think I'm actually using it. No. No, I am not. F automation test base. Let's just refer back to the documentation again. That is actually not in there. F automation test base. So what is F automation test base? Simple object based class for all automation tests. Oh, I see. It's to is it to yes, I see, I see. This is actually used up here, is it? So yes, there it is. Aha, okay, I see. So that is required, and that's a good reason why we've got that. And the element factory, I suppose in a way I don't really want to just new up the one, so I think that's probably safe to do that. And then the next one will be bool test, that'll do, and then it'll be automation test base. Well, it'll be that, but actually maybe even just new object will do. New object of u element factory. So now I see what the make shared thing is for. Okay, so this is trying to protect against. So I guess you can't do a U object for these services, and maybe they're not required really. They're probably not required. Let's just test this fully first. T object pointer, and then we're going to go test equal. And so test equal. Oh, add log item. Variables remarks. F automation test base. F automation test base is the top level, so where is everything? Slightly strange. Okay, well, let's just do test that element factory let's go assert, no, arrange at, and this will be where I'm going like that. This is create element with that. Let's actually declare these up here. and then plop these in, and then we're going to assert that the U element T object pointer returned is not, so I expect uh, I expect it to be true, and it's going to be that. So let me just expand this over and let me zoom out a bit. I think it's going to have lots and lots of problems with this, but let me just think. So if this one's wrong, so I need to do that. And then this is wrong, but I'm going to, um, it should, it should, uh, just do that. It should create element. Yeah, and then we'll go and call that. So instantiate the wrapper for the test, execute the tests. Return true if they pass. Okay, lot done there. Let's go see what's going to happen. I suspect none of this builds because we've made it a UObject, the service. Yeah, lots of errors. Let's see how silly they are. So, first things first. Should put this in here. Find all in current document. So it says, cannot open file atom actor. So that is in science tests module. Science test module, that's correct. Not a thing. Next. Oh, yeah, that's right. Syntax error missing before class head element factory dot h. So factories, where are you? Is not there because we haven't compiled it yet. So let's try that again. It's just building now with the new stuff, so hopefully less silly stuff. Okay, output. So now we got syntax error missing class. So element factory.h is missing something. Element factory, factories, element factory, UObject class. So I think that's probably the problem, right? Is that we've got multiple inheritance going on. But I must remind myself. Ah, no, hang on though, because I haven't actually included um, the interfaces here. So, and I think I need to include the proper interface because otherwise it's not going to know that this is not following the correct. Or maybe it doesn't need to do that. Anyway, let's try it. Okay, next one. I can't see this. Too small. How do you make the size bigger? Increase text size in Visual Studio output window. Show settings for output window. So tools, options, fonts and colors. Ensure show settings for to output window. Ah, I see. This needs to be like 14 or something. Ah, yes, better. Cool. So this says missing before class head. So I guess it's not a U object in that case anyway. So let's just check what this thinks. Testing, services, abstracts, iService.h. It's a struct without U object. Yeah, that's another one. Now what? Missing before class head. Yeah, so I don't know if you can do that. So if I were to do, like, let me actually just double check C++ anyway, because I can't actually remember. C++ multiple inheritance, if you have to say public on each one, which is I can't remember. You do indeed. Now I don't think this is going to work, uh, and so that's why you can't do inheritance for your object, but that is such a problem because then your service won't be able to do anything. So your struct would have to inherit from it instead, but I don't think structs can inherit from them either. Annoyingly. So let's also go back to the Unreal Engine things here, because I'm guessing the interfaces they declare they're all this 0 thing. Let's try and see if we can do Unreal Engine struct inherit from U object. You can have an array of structs, but you can have an array of other structs. There is no struct graph where you can struct things though. It's just a collection of data that is used to access. Normally you'd have an inventory access. Um, yeah, I wonder if a normal class would do the job of an interface, but also there's also Unreal Engine interfaces, but I just don't think that's what Unreal Engine interface with T-type container. I don't think it's going to do it. And let's see what T-type container actually takes. So if I go back to here, my actual tests, no, my game instance. Here it is. Uh, I don't know if it may or it doesn't care, apparently. So maybe, just maybe, the factory can be a the I Atom Factory could be an interface in Unreal Engine. So let's just check that avenue out. Unreal Engine interfaces. 5.1. And it says, are useful ensuring that a set of potentially unrelated classes implement a common set of functions. It's very useful in cases where some game may be shared by large complex classes. And does it, let's see, test. Nothing about testing in here. Testing. But let's see, it inherits from uInterface. Um, and then you have the class underneath. And I guess uInterface, let's see, is probably inheriting from uObject. It is. Okay, cool. So that would actually work. That would actually work. Then you can inherit like that. Ah, and you could do multiple inheritance. Ah, now that is interesting. So let's do that instead. So I'll side by side this. Let's try and figure this one out. So this is going to be a pragma once and include, oh, that's a bit annoying, and include generated. Yep, let's do that. That's going to be an element factory interface. Let's try that again. And that'll be a U, and that'll be a class. And this will inherit from U interface. Yep, and then it's generated body. And then underneath we got a class of I element factory. Oh, I don't know why it's called interface twice. Okay, well, I guess we'll just go with the flow. And then that will have the function on it. And this could probably be now a U function. Though I don't think you can do that, so maybe just that is fine. And maybe just that is fine. So let's go and look for an interface in Unreal Engine. Unreal Engine interface with method example. C++. Yeah, okay, cool. Generate interface body. That's not on there. It's generated body, yeah, okay. So I can do that now, which is cool. Maybe I don't need that. And expose t name of I element factory. And then this U interface is going to be, oh, U interface here I see, like that. Don't want this to be blueprinted. minimal API, I don't know what that means. Okay. So now we have almost everything done. Element factory interface is what it's called. We inherit from this, we do that, we've got the class, we've got the generated body, we've got the public and the function, and then we're exposing that because of the dependency injection. So let's go and redo this. Sorry if anyone's talking to me, no they're not. Not a lot of biology being done here, or physics. Anyway, great, lots of errors, always good. So let's check out these errors now. Might be slightly different. And it's saying that, well, that's actually not part of the build, funny enough. Output, there it is, okay. So this is saying interface functions that are not blueprint implementable events must be declared virtual. And this says, yeah, that's right. So I element factory interface, which I guess I need to include. Fine. In fact, probably should use this all the time. I don't really know what the, because there's no quotes then, right? And this will be registered with an element factory. Can I do that? Okay, doesn't seem to worry about that. Well, I'll tell you what. Well, let's avoid any absolute confusing at the moment. Let's do u. Let's just do it. Element factory. U element factory. I element factory, and that would be public. And create atom will return wait. This is wrong. Create element. I thought I changed all this. A element actor. That's going to be a T object pointer. And this is going to be a class. Because why not? Yeah. So okay. So that's the interface. That's the thing. And this needs a bit of that. U functions cannot take a T object point as a parameter. Let's just look at that. Still not found the real reason. Any details about why? Some to open. Okay, fine. That's fine. So we're going to do a pointer returned, which is weird, but whatever. And that means that the element factory itself needs to be changed over. It's a bit annoying because they have said that and then it doesn't work, right? A bit odd. Next one, cannot open iElement factory. Uh, that's right, should be factories. Factories, iElement factory. It's going to be element factory interface. And it's also interfaces. And this needs to be that that's correct. Factory interface, that's not. And then it says uelement undeclared uelement factory. That's correct, I haven't declared it there. And types container needs to know no matching overlay function found. The type of class to register an instance class for. Let's just build this again. Cannot open include generated.h. So element factory is actually correct, and it's uElement factory, uObject, and then you've got the interface, and then this is going to be an override, right? Like that. Cannot open include file. Why? It's not uObject, it's uClass, that's why. Haha. Okay. And what does this say? Unable to find class with name uElementActor. But that's fine. Return type is not identical to nor covariant with return type aElementActor. So I think maybe this being oh yeah, that's it. And uElementActor, I don't even know what that is. Okay, let's try that now. Okay. Wow, now we're getting somewhere. Oof. Undeclared identifier. It's not that, it's an aElementActor. And that means I need to include it. It's going to be actors element actor. Well, okay, let's just do that. Next, test equal is apparently not a thing, but what is it? Oops. Test equal is a thing. What actual expected? Why do I need an actual and an expected? Uh, so what is equal element? So actual expected. What? Actual expected element should be true. That's it. That is the. Why is that not seeing it? Ah, so f string what? F string actual. Maybe I need to equals null pointer. Let's see if that's. Lots of f strings. And this is not coming up as something with type ahead, which is very frustrating. Let's just double check this type. This type's include. Yes, it was right. Yeah, so I don't know. Test equal floats, doubles, no booleans. Ah, test false. Ah, there you go. Test true. There, awesome. What value? Description text for the test, the value to test. Okay, we see. I understand now. And I guess this one also had that, but anyway, test true. Um, element was create. Element is not null. And then this will be the test. Awesome. Okay. Bit crazy, but yep. Let's try the next one. And then we got T object pointer is not a member of U element factory. That's correct. It's not, and also it's no longer doing that, is it? It's going to return a pointer because why not? And element actor needs to be A. Don't know where you came from. Oh god, this is so crazy incredible. Error must return a value. Ah, I see. Uh, so what did I return on mine originally? Um, let's see. I just returned true. Okay, that's slightly odd. And then what's next? It says operator new convert all arguments. Okay, so this is the itty bitties now. Here we go. So let's see. It starts with saying operator new under the two overlays all the argument types. Make shareable get instance. So what is this for? Register class. Um, it might be that it's not going to work because of the things I've done here. So having it as a double up here. Um, but let's just make sure I'm not doing something stupid first, so which is quite common. And also, that's supposed to be there. So I'm registering I element factory interface, which is a thing. There it is. Um, and it has a create element on it. And it inherits from U interface. Operator new. None of the two overloads can convert all the argument types. I guess it's because this does not have um, yeah, it's not newable essentially. But that's pretty much what an interface is supposed to be, right? So registering a class, the type of class of register an instance class for, the type of class of register must be the same as or derived from R. The constructor parameters that the class requires, and scope, the scope of which instance must be unique. So I suspect it can't make an instance because of the obvious. While trying to match the argument list, see reference to function template instantiation. Being compiled, make sure I will know. I tell you what, let's comment out. Let's try and get to the actual matter. So yeah, there was something I didn't like. What else is here though? It says um, error, unresolved link, unresolved external symbol of A element star. So I don't think it likes the classes being used as well. So let's actually include that. I mean, it might not be that, but let's just try it anyway. Include with actors dot uh, electron actor dot h, and then actually in this one might not matter actually, and then this one's got an error of unresolved symbol 2, and that is on the interface. So if I go there now, because I've added that, I probably need to virtual class element actor, unresolved external symbol. So if I add that in here and remove that, is that going to return that properly now? It still doesn't like it, so unresolved external symbol, public, virtual class. C declaration, create element. Um, do I need to put virtual here? Or do I need to just, I don't know. I don't think that's right. Yeah. it's just saying that I'm not matching the function here, but I'm not so sure. I think maybe it's worth double checking the interfaces guide here again. So they have got an interface with U functions, um, and then reactor high noon. And then, yeah, okay, so they're both got the functions on them. Ah, no, that can't be right. Do you need an implementation there? No, but you do need, that's what it is. Implementation. That's right. And I don't think it needs that then. And then create implementation, element implementation is not a member of U element factory, but it is through interface. No, it is through, yeah, being an interface. So I think then you have to actually define both of them, which is so, or maybe you just have to define, it can't be right. Like, are we sure you have to do that? Like you do that and then you do underscore implementation. That can't be right. And I guess, do you even do override? Virtual override. Oh god, this is horrible. This can't be right. This is not how interfaces are meant to be. Unreal Engine interface C++. The thing is, it doesn't bloody tell you, does it? You can declare a virtual C++ in your interface's header file with no U functions. These functions must be virtual so that you can override them. Uh, I see. Okay, okay. So I probably don't need that. Let's go back to here. I don't need that, and it wants me to do a virtual, and then I can probably do that and override that. What is it not like now? Syntax error, missing that before. Oh, dearie me. Um, you can declare a virtual C++ function in your interface's header file. So here it is. Here's a virtual C++ file thingy. I've done that. These functions must be virtual so that you can override them in class to implement your interface. Okay. And then you can then provide a default implementation either with the header itself or within the interface's CPP. When you implement your interface in Actor, you can then create and implement an override specific to that class. However, these functions will not be visible to Blueprint. So I can't do that, I wonder. To make a Blueprint callable interface, you must provide a U function macro in the function's declaration with the Blueprint callable specifier. So I guess reactor trigger. Functions using Blueprint can be implemented in C++ by overriding a function with the same name, but with the suffix that. So do I not need that in this case. Whew, this is insane. Why is it so difficult? Create element function definition for create element not found. So I don't think I've used one of these for a very long time. Maybe maybe I do have one in there though. Let's have a look. Yeah, so you can do functions in the interface, and then let's see, interactive interface. Let's see if I got this. And then let's see. I've then got this. Oh, I see. Oh, I wouldn't have known that. Okay. So if that's a U function here, then this will be, I mean, I'll just copy it and I'll do implementation here and with override. And that needs to be here. Alright, let's try that. Aha! So method with override did not override any base classes. Create element method with override specifier override. That's interesting. So then I have to understand how this is working. So that is there, but it's not virtual in that case. Interface functions that must be declared virtual. Interface functions cannot be declared final. So if I were to do virtual and do that, then it's a whole different. So if I did this, but put something like this, I wonder if this would resolve that now. Now what? Unresolved external symbol for create element. So this should be well, maybe I will call it. Maybe that is a bit silly actually, I'm doing that. So then this would need to, that's inheriting from that. Then I've got my override and it's the implementation. And then that, this is giving me a headache this. It's so ridiculous how it's written. It's very odd. And then that here needs to be implementation, which it is. And so this is now doing that, but it seems that I also need to include the other one, which is a bit strange. So I need to do this as well. Which is so, it just cannot be right. Uh, it just cannot be right. And this says unresolved external symbol for create element. But it has resolved the other problem because now I've got the implementing thing. Oh, goodness me, dude. What is this? I've wasted so many hours on this now. Um, it says referencing function. Ah, hang on. This is different. A result it sounds simple. Create element referenced in function. Protected virtual bool. Hang on then, hang on. Have I just solved this? If I do that, what's happening here? It's saying virtual create not permitted on data declarations. But without it, it doesn't like it. So then I have to do u function, but make it virtual. Is that what it needs? Maybe that's the problem. Yeah, okay, then back to where we are. And then error, implementation method with override specifier override did not override any base class methods. Uh, so let's try without that. Because I think the interface creates that method, so I have to say I'm a bit confused at that. Unresolved symbol, where is this? On the element factory. Unresolved external symbol, public virtual class element. Create element in. And that's why that needs to be that. And then it's saying create element input is not a member of view element factory. Then if I do that, it's not going to work because then that also needs unschool implementation. This is saying element factory unresolved symbol element create element. It says unresolved. Oh God, can someone not come on and help me? Unresolved external symbol public virtual class element actor create element. Unresolved external symbol. So how is that not? It's there. Do I need to do the override? If I do override, let's see what happens. Now it's saying this is on the same file, create element, unresolved external symbol virtual class. So then do I need to say it's virtual as well? I don't think so. Now it's saying linker, unresolved external symbol, virtual class element actor. I don't think I've got that anymore, right? Yeah. Um, create element. So if I go back to the Unreal Engine thing, So we've done that, but I really wish the U prefixed class needs no constructor or any other functions, while the I prefixed class will contain all interface functions. All classes listed will be compiled before this class. Causes only the class's type information to be exported for use by other modules. The class can be cast to the function. Okay, so I took that out, so let me put that back in as well. Yeah, and it says, with the exception of inline, this improves compile times by not exporting everything for that class that do not. Okay, cool. And then implementing your interface in C++. It says, make it public, cool. Add interface function overrides here. There are several methods you can use to declare functions in your interface, each of which is implementable or callable in different contexts. All of them must be declared in the I-prefixed class for your interface, and they must be public in order to be visible. C++ only interface functions. You can declare a virtual function in your interface's header with no U function specified. So let's do that. Nothing in there, but it must be virtual. It's public, it's virtual, we're good. Then, you can then provide a default implementation either within the header itself or within the interface's CPP. When you implement your interface in, I mean, why? Okay. Return null pointer. When you implement your interface in an actor class, you can then create and implement an override specific to that class. So now we've got the override. I don't really want it to be virtual because it's not going to be underneath, but let's just try it anyway. And that should be like that. So now what are all the errors? Because we've got a shitload of errors. It's saying that it doesn't error, syntax error, missing before pointer. And let's just make sure generated body public, and then this one is generated body public, a U interface, minimal API, blueprintable. I don't think that should make a difference. It doesn't. Good. Um, implementing your interface. I swear I've done this now. Okay, so we've literally copied that word for word. I'm happy with that. Add interface function declarations here. Reactor trigger, trigger C++. When you implement your interface in an actor class, you can then create and implement an override specific to that class, which I've done. Yep, 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 yep. However, these interface will not be visible to the blueprint. Cool, well, that's what I want. So what is it that's wrong? Maybe because it's not an actor. Yeah, maybe it's because it's not an actor. Because it's talking about an actor class here. Interface for U object. How chats may be derived from actor enemies from a special point. All these classes need share, but have no common ancestor other than U object. In this case, an interface is recommended. So I guess you can't do this. Um, you can't do this. Is my thoughts here. I'm guessing if I were to do this on an actor, for example, like so, I suspect it will start working. Um, let's just get rid of that for a second. Cool. Um, that will go over to there. Just try this out. I have a funny feeling. Oh, I don't need that anymore. That's good. Element factor. But this is going to start working. So now I've got that. I've got my override of it and the factory. Um, get rid of that. Get rid of that. This is not fun. Unreal Engine, this is not fun. I've spent 2 hours on an interface. I've now literally copied its thing. I don't get this. Be right back. Just gonna go to the toilet. Ha. Got to the toilet. There you go. Alright, let's see if we can crack this. This is ridiculous. I don't think the error message is really saying much here because it's like syntax error missing semicolon before a star. Like, no, I've got the type, the sorry, the keyword accessor, name, so parameters, and the function. And then it says A element actor virtual not permitted on data declarations. Data declarations, what? A element actor pointer not permitted on I interface A element actor. So like something is happening inside this that's a little bit strange. So I think maybe if I go to this intermediate folder. Oh, is it binaries? Oh, that's just strange. Where is that? I think it is in the intermediate. I'm not sure why it's not coming up. So if I go intermediate, yeah, it is. I don't know what's going on there. Let's go back to the thing there. And if I go to build, well, maybe I can just search for it here. Yeah. Um, let's drag this in here. So it's saying line 21. No register. Implement class no auto registration. So it says virtual not permitted on. Ah, hang on. Hang on a second. Is that all it was? Why did it take so long to bloody type ahead for me? Oh my god. Amazing. So what's this saying now? It's saying create element isn't something on a factory. That's correct, it's not. So okay, so we got that to work now. It was a silly mistake. Visual Studio, that's ridiculous that you weren't showing me that mistake. And I say that C++ error was so confusing. Oh god, I look ugly. Um, so then, ooh, my. Okay, right, sorry. Okay, so now I want to put this back from here. So if I go to my, is it up quark or down quark? I can't remember which one I put it on. This one. Uh, delete that and put that back onto the element factory. There it is. Put this back on. Is this now going to whine? Is the question, because it's not an actor, right? Which I suppose in a way is kind of fine. Let's see. It's saying create element unresolved external virtual class element actor. So I think it's quite possible I'm doing a silly mistake here again. Electron is not the correct one, it's element. And what have I got up here? Element. That's correct. So let's try that now. Ah. Okay, so now for the actual biggest problem. Well, let's see if this works actually first. go on. Because sometimes on runtime it's like, oh, actually I don't like this in the end, so I'm just gonna give this a try. That's cool. Okay, that's good. Fine. So now let's try and put this back in here, which I don't think it's gonna like. No. Um, it's registering a element factory, I element factory, di, registering a class, and the errors are quite crazy, and it's because I don't think it likes none of the two overloads can convert all the argument types. So I think after all of that, it's not possible like this. So what I'm gonna try instead is if I do struct I element factory interface, sorry, like that, and then I copy this out, don't implement it, like so. That has to be virtual, yeah. And so now, if I inherit from that, I lose the opportunity of being an U object, I think. Because I don't think you can do multiple inheritance like that. Though I'd be happy to be wrong. And then that will be like that. Well, yeah, we definitely can't do that, so it's fine. Sure. And then I suppose, what is this saying? None of the two overloads can convert all the argument types. Is still a problem. That's interesting. And so this is definitely a struct. And let's go back to the documentation. Struct, yeah. Virtuals. Am I inheriting from it now? I guess I'm probably not actually. I am actually. Register class. Let's just double check I'm doing this register class right as well. I think by default it does this. It makes sense, right? I could look at the thing, but I'll just look at this instead. Register class. It's here somewhere. Source. No, let's go back to the start. It's on the main game instance. No, it's not. It's there. Yeah, and that's cool. So that should be fine. Yeah. And so operator new of the two overlays cannot convert all the arguments. Make shareable T function instance provider. And I think it's probably because, I mean, let's just try this first. Does that now, so it has less, unable to find parent class for U elementary factory and I element factory. Unable to find parent class type for U element factory named I element factory. Unable to find it. Ah, there's a idiot, yeah. Let me just double check that it's needed. I haven't done this stuff for ages, so I don't know if you need to do this. The structs with publics. I guess you don't, but let's go here. No, let's go back to here. You do. Okay, that's good. So this is now correct. Yeah. Um, then we're exposing that. Then we are inheriting from it. And then we have the create elements there, and it's overriding it. And here it is with the implementation element actor. And then this is saying unable to find parent class type for U element factory. And this is in the element factory.h. And that might be because unable to find parent class of class type for U element factory named I. Why is that not visible, I wonder? For example, if I were to just put it in there like that, is it gonna see it? The generator was detected in a block being skipped. Was this intentional? Um, and there's an error, but there is no error. A block that was detected in a block that's being skipped. Element factory.h. So what's interesting to me is maybe if I do that, and then I suppose I need to do that though. Still unable to find U element factory, I element factory, element actor, I element factory, and we're including factories, interfaces, element factory interface.h, and cannot find it. Unable to find parent class. Element factory.h. It's unable to find the parent class. Um, Maybe because it's generated stuff, so I need to get that to generate it again. Oops, didn't mean to do that. Yeah, it could be that because it has done the generation of that class, it's got like all this kind of generator.h stuff in it, and maybe that is actually causing concern. But it didn't seem to reload anything, so unable to find parent class type. And am I doing something stupid here? Is it U class or is it? So that's fine. Oh man, I am bored of this now. Gosh. So we got um oh, the links have gone. That's great. Let's try that again. Oh dear. Oh, how annoying. Links have gone. Maybe if I go to master, maybe that's better. Okay, cool. Uh so if I go to this file, common.h, pragma once, let's just make sure it's all there. Pragma once, and then you've got the struct called IElement factory, declared that. We've got the actual thing equals 0, great. We end it here, we expose the name IElement factory, element actor, and then this cannot see it. So if I go down to this, it's going to be the player service, and it does not like that. I see, I've got you. I see, and also that's not going to work either. And that's not going to work either. And that's not going to work either. Anything else? And what is the actual problem now? It's probably something different. Static class is not a member. Okay, wow. Yeah, let's also now recompile this. So I don't know what problems this is going to have, giving it it's a service. I can't. I can no longer now like get world inside it, which is a bit of a shame. Static class is not. This is in element factory. Now it says C declaration of view element. So let's get rid of the U because I think it's maybe thinking it's something special. Which means I need to go back to my test. And that means I can't use that, so it's going to need to be shared. But actually, I'm more interested in just like not even trying at the moment. Was that the problem? It's not a class or namespace. Now what? Fatal error, one unresolved index container, unresolved external science game instance. Right, but I did. Did do it here. Unresolved external symbol, public static class. Okay, I think I need to. I think I need to actually declare it in here, don't I? When it's static. In fact, I'm pretty sure that's what the problem is, and I can't remember the syntax, so luckily I have already done this. Source testing. I see that. DI, and we'll just call it DI in there. Oh, no, can't do that. Don't add files in the filters. That's a bad idea. Is that public? Yeah. di.cpp include. Come on, Copilot. di.h, and this is going to be di. Is that right? UDI. UDI. Container. Let's try that now. Oh, I need to regenerate. Reload. Rebuild. Rebuild again and again and again until it comes. Okay, I need to go to this. Alright. Okay, so now for the next part, these. I need to do that make shared thing. Make shared, and it's going to be new, like that. And then this will give me a t-shared pointer. Make shared pointer maybe. Can't remember. Where is it? It is a make shareable. And this is a t-shared ref. Make shareable. Where's that found? That is in there. And then that's supposed to be that. Like that and that. T-shared ref. T-shared ref. Yeah. Good point. That's supposed to be I element factory. Make shareable does take that. I do new it up. Element factory is a thing. So what's the complaint here, guys? Element factory doesn't like that. Factory is element factory. How odd. So element factory is definitely in factories, and there it is. No instance of overload function make shareable. T shared ref. I element factory make shareable. New element factory. Ah, because it doesn't have a constructor. Of course. Yep. My bad. Okay. Doesn't need to do anything actually. And now what? um, Syntax error. Identifier element factory. New element factory. Oh, do I need to do anything with that? No. Not player service. What does it actually look like then? It doesn't need that either. Um, yeah, and I suppose it shouldn't really. That makes a lot of sense. Element factory. It shouldn't need that. It's a class. It's got a public high element factory. It's virtual. It's overriding. Um, it's there. Element factory. If we go to the tests, it's that. I've got it included up there. Um, make shareable is a thing, right? Maybe they've done this now. That might be the case actually. Make shareable, no matching overloaded function. So what is this? Object type and then what? In objects. Okay. So I need to do that and then that? What's the point in that? Oh, no, no, no. This is wrong. This is wrong. Oh boy. Make shareable. Don't need that. Definitely don't need that. That's ridiculous. Um, hash include. What's the normal include? Core minimal. Maybe that's what's going wrong. Let's try that. Nope. Doesn't need that. And I'm inside. Ah. So I guess you can only do make shareable inside here. Is it? Hmm. Guess not. Syntax error. Identify element factory. Like, there's not another class called that or something, is there? This one says T raw pointer proxy. T raw pointer proxy. Object type. Make shareable matches the argument list. And this one, it does say that it needs this. I wonder what an auto does. Let's just try an auto for a second here. Oh man, this is insane. So that's totally fine. Make shareable. Make share. Make shareable. The following is an unrelated extension to standard SharePoint behavior. And you do that an in object and a deleter. But the in object and deleter is not required, but it does want the object type. So if I then did that, is it that the object type is not the right sort? Let's have a look. Object type. Make sure wrap object pointers make shareable to allow them to be implicitly converted to SharePoint. This is useful in assignment operations or when returning a shared pointer from a function. I mean, maybe I can just do new element then. Like that. There's something screwy about this element factory, I think. Public factories, element factory. This is fine. Yeah. I wonder what is not liking. I wonder if that's... I mean, it knows what it knows is there. Expected a type specifier. This can't be right. This cannot be right. I'm gonna clean the solution. Something is amiss here. something I think is screwing around. Element factory.h, and I've got element factory.cpp. Element factory, create element, takes all that stuff. Element actor, element factory. Um, I don't think the element factory needs a CPP file. I don't think so. Let's have a look though. Testing. Services, abstracts. Okay, fair enough. I do have that there. But is there anything in it? No. Maybe it does need it. Um, if it's gonna be an Unreal Engine or something. Not really sure, to be honest. Let's just try it. It might be that it needs a CPP file. I just can't think of anything else that's going wrong. I element factory. Let me just put that into there, and we'll call that. Oh, it's done it for me. Wonderful. Hang on. Yeah, no, it has. That's amazing. Well played. Oh, no, it hasn't. I'm an idiot. No, I'm being an idiot. Okay, cool. CPP. But this one's going to be empty, right? This is just going to be factories. And factories, interfaces, element, I element factory. Let's try that. Cannot factories, interfaces, element factory interface, I element factory. Since syntax error identifier element factory again. Ah, uh, yeah, we knew that. I element factory interface. I element factory. So that's working now. So there's something very strange about wanting to make a new element factory. And I don't think you need a constructor to new up elements, but I'm happy to put one in. So it's not that. And this, I don't suppose it's that problem. A syntax error, identifier, element factory, and auto. Um, it's strange because you know what it is? It's it's this. This is not loading it in. So the module is not seeing the type. That's what it is. How do you get that in there then? Um, Let me think. I think I've got some. I think I've got some modules here that might give me a little little idea. Sorry. Let me see if I go back a bit. Yeah, something like that. Yeah. Okay. What do we have here then? So this. Um, Apparently needs in it. Uh, that's fine. That's fine now. Oh no, no, I see. Let me just check this though, because I'm not sure what I'm doing now. Something's changed. Uh, okay, maybe not that. But in this public, I wonder. I see. Maybe that's the problem. Something like that. Let's Google it. My Unreal Engine C++ module cannot see game classes. Um, or Unreal Engine module. Loading phase. Uh, yeah, maybe I did do that wrong actually. Okay. Now there is another thing here called extra module names. let's try that. Does not exist. So what does that replace with, I wonder? Ah, that's not in the build, it's in the target. Okay. So if I go into here, modules and target files, Unreal Engine. Oh, oh yeah, interesting. Modules. I think that's fine. Target assess, extra module names, add. Target.cs. Aha. Regenerate. Let's try that now. Nothing changed. Stop talking, I'm just so tired now. I don't know what's wrong, so this is not helping. I'm just adding bits now for no apparent reason. I hate when I do that. It's just the worst. Because I just can't see how the documentation on Unreal Engine can be missing something. Like otherwise lots of people complain they change it. Right? So I must be missing something very, very strangely obvious. And what's this other member function declared with override does not override a base class? Uh, and that's going to be for that, isn't it? And maybe, okay, so here's another thing. Let's just try, if I do that, get rid of that, and now go to my test module. How's that looking? No, it still doesn't look. Create element is not a member of. Okay, true. Nothing's changed. That's good to know at least. Ah, but it is still saying like fuck off there. Um. Oh no. Oh no. What an idiot. Ah. Oh no, James. Damn. That's not cool. That is not cool at all. Let's just make sure none of that was needed then. Oh, bugger. It will, it will. Oh, that's so annoying that I missed that. I'm getting bored now. Unresolved external symbol, A element. What file is that? Element factory test.cpp. Yeah. So I suppose now I could probably do that there. And I'll just do this here. Uh, it's interesting because that's in a way that's why you do lowercase naming conventions in C sharp, as I have done that before, and it's a bit of a pain to catch it when you miss it. Right, what's this saying now? Fatal error, one unresolved. Science game instance.cpp. What? Fatal error. Unresolved external symbol A element actor on elementary factory test.cpp. Element actor. I actually think it needs to be that though, doesn't it? Unresolved externals. Error. Unresolved external symbol A element on element factory create element. Oh, have uncommented that yet? Okay, cool. What now? Virtual class element factory create element. Do I really need to do that? It's quite surprising if I do. Unresolved external public virtual class A element actor create element. So it's saying that this is not resolved. Element factory. um, Core minimal factories. Ion factory. This is here like that. Cool. That is create element there. And it's saying it's unresolved in the tests. Unresolved symbol. I guess element factory and then actors element actor. Um, Create element is there and it returns an A element actor. But it's an unresolved external symbol. Hmm. Bit confused at that. This is absolutely saying expected science test module to be first header included. Expected science test module.h. Oh, okay. Let me look at that then. Science test module. Oh, it's not there, is it? And it's expected science tests module .h to be the first header included. Why? Because I added it probably. Um, and then this is saying unresolved external symbol. The command member function declared with overrides not expected science test module to be first header included. That's right. It should be. I see now. And let's just grab those again. Well, yeah, fine, fine, fine. Okay, what else? The also unresolved external symbol on the test for create element, and yet create element. It must be because it needs to have the interface, which I didn't know. I had no idea you had to do that. Factories, interfaces, by element factory. Interfaces by element factory. Solved. Create element. Which is a bit strange. Because it is public here. It's got an implementation. Do I need to just do that maybe? Cannot open, so that's not it. Whew. Oh, that's wrong. At least. Um, yeah, so that's all good. Oh man, this is ridiculous. I hate C++ now. Fatal error link. Like, why is it so confusing? Unresolved external symbol in CVP object, whatever that is. Unresolved public virtual class A element is the element factory, create element element factory, element actor. Unresolved external symbol, public virtual class. It's unresolved symbol. Um, And I don't remember. So when you do these ones, uh, so it's how to declare um, virtual equals 0 C++. What's it called? Okay, equals 0. No, go away. Oh, what is this site? Oof. Animal. Yeah, okay, yeah. So that's fine. And then um, that's that. Um, class element factory, create element, I element factory. I'm doing a .h and then I'm doing a .cpp. I've included it. Element factory, create element, takes these parameters, returns something, returns that. Um, um, this doesn't need a generated. I've included the interface. Oh, look, it's not there. It's actually too. Where'd that come from then? Don't want that there. Ah, that's the problem. Cool. God, that was a bit difficult. Phew. Is that gonna work now? Please? Still similar problems. Create elements not existing. I've got a CPP, got a CPP. This has got an H. Uh, I mean, just for shits and giggles, let's put that virtual back in just in case. I didn't think so. It's still in the tests, it doesn't like it. I'm guessing there's an H and an H, yep. It's definitely in there now, iElement Factory. Um, yeah, that's correct. Oh man, I just don't. There's lots of little things I'm doing, but man, it's not obvious. Unresolved external symbol. Maybe it's time to do a clean again now. I think I might have to call this one. It's so strange. I'm having such problems with it all. Um, I didn't really want to do anything like this. I'm very surprised that test cases and just the general errors that come back from C++ and Unreal Engine are not obvious. Like what does this even mean? If I've got it's trying to link science tests and it's saying like it can't find it, but at the same time, I guess if I go to the science test module, sorry, to this part here, Visual Studio is saying, yeah, everything's fine, right? So I bet like if I were to comment that out, it would still be a problem because it's probably hasn't even found Element Factory. Of course it hasn't. So it's like it's so confusing, um, and I'm just wondering, was this the right thing to do? Science tests? I just don't know. And also you've got to keep doing this. It's just such a mess. It's such a mess. Oh my lord. It shouldn't be this hard. Really shouldn't. So that's not it. But the problem is that it can't see that thing. So this probably does need public. I'm just going to try this again. Public dependency module names and just do that. If you go back to this, it says public add range, and it's got your project name in here. So um, I don't think I need that. So now I've got that. I mean, maybe I could just change that over. I don't know. And then is it more that I just need to build this again? I don't know. And then I've got that. I've got that. I've done the module. I took the loading phase out. In fairness. Let's look at that again. Let's do that. So it's not that, is it? Unless I guess I suppose I have to do that again if I've added that. But this is when it loads, not on compilation. Yeah, nothing changed. And then what else? So now the target extra module names. This target is saying I need tests. This is saying I need tests. Once again, I guess if I do that, we're gonna have a fun time. Yep. So let's go search again. My Unreal Engine C+ module cannot see my game module. I wonder if I can just take a look at, let's say, Unreal Tournament, right? So I'm gonna go into Unreal Tournament source. It's gonna have loads of modules. There's one, yep. Cool. So let's go to the GitHub stubs. There it is. It uses engine. Maybe blueprint context. Unreal Tournament. Public. And then module. Mm. Yeah, and they're not adding targets here. So I guess let's look at that. And then blueprint context. So if I go back to here again, it's not even mentioned here. Cool. This is literally just added in here as a public. That's interesting. But I think I think I've got that already. So if I go to this, it does already say public, and I suppose I could just make them all public, but I've done it anyway, right? Doesn't make any difference. Um, the target is just not, it's not required. The build, science tests, science test module. I think that's what it's called there. Let me just go back to this. Field context. Ah, that is interesting. Right, that's the problem. It's because this is called science tests, but then we are declaring it as science tests. Okay, startup module. Let's see if there's a startup module. Ah, that's interesting. And then this is elementary factory tests. This is what uh, pretty name, editor context. Okay, and then you got run tests. What do these dependency modules actually do? Modules are building blocks of UE4. The engineers implemented a large collection of modules. Wrong one. So yeah, that's another thing. Like there's a buttload of modules here. So surely I should be able to figure something out from here. And this takes from oh, I don't even know what I'm looking at anymore. Oh man, this sucks. Uh, this is private as well. It's just interesting how they've got private there. Um, and this is talking about list of private dependencies. These are modules that our private code depends on, but nothing in our public include files depend on. List of modules name with header files that our module's private code files needs. List of modules names with header files that our module's private code files needs access to, but we don't need. I wonder if okay, because my my private files, it's the public files that need it. So public files are accessing it. Let's just put this back. I don't know how that is, it just does nothing basically, and that is probably not needed. Anyway, um, yeah. So I think maybe because I need access to the private, it needs to be telling me like it's all good, you know. So I would say something like that. Not entirely sure. Um, Still a linking issue, and now we've said uh, private include path module names. We've said list of private dependency module names. These are modules that our private code depends on. So our private code does not depend on this. Neither does our public code. So none of this is required. Um, I don't think so, at least. Whereas the other one does require. Ah, that's because it's no longer building it, right? So that's why we have to do that. I see. I see, I see, I see. Because we want it to build as we build. Fine. And then this requires both the public and the private of science. I wonder if that makes the difference. And the target file, what is that for? Targets. Targets are declared through C# source files with the targets and are stored under your project's root directory. Each target file declares a class deriving from the target rule space and sets properties controlling how it should be built from its constructor. I don't know what that means. Same as game, but does not include any server code. So I guess what I what this is saying is that you can make it build, but the thing is, my game does actually need to run the unit test, so I think it's fine. I wonder, I wonder though. Let's see if there's a YouTube video for this. Sure. How to create Unreal Engine module C++.
Showing up on the first page of Google might not be the best for everyone.
Hello guys, to the first person template. Okay, here add a new module. Let's folder, go to the source and manually create a folder for our new module. For example, new module test module H, test module CVP, and test module BLCS. Let's copy it, create here folders, public, private, and paste it here. And let's rename it here.
Okay. So if I go here, what have I done to my own thing? Uh, yeah, I didn't. I've put it in there, but maybe I shouldn't have. Maybe it needs to go outside of there. Let's keep watching.
New module, paste it in a public folder,
Okay.
and the CPP file, new module, paste in a private section.
Okay.
And new module BLCS remains here. So we need to go to the private new module CPP file. First of all, we need to change here the name of the header file for new module.h. And here we need to delete the primary from the implementation macro. So we need to have implement k module,
Oh.
name of the module here, and the name of our game as a test module remains as it is. Let's go to the build.cs file, and we need to change the name in the same way as in previous files. Okay, so let's close it. So let's generate Visual Studio file. In the fourth step, we need to open our new Visual Studio project after the renovation, and here we can find our new module folder with all these directories here. Next step, we need to go to the test module target.cs file, and let's open the test module editor target.cs to reveal our module in the editor. So we need to copy this string, extra module name, and add our new module. And the same thing we need to make here. Copy, paste, module. Awesome. In the last step, we need to go to the test module view project and add here to and to our new copy, paste,
So he's done that to both of them.
copy, paste,
Let's do that.
module. Oh, sorry. In the last step, we need to go to the testing view project and add here our new model by the copying and changing just the name. Generate our new Visual Studio project file. Rebuild. So let's see in our project. So now we don't see our new model because new model don't have any file inside. So to see the new model here, we need to add some class. For example, new actor. Let's name it test new module actor and choose here the new module runtime. Make it public and create. So at the first time you can get the error. Don't worry about that. Say yes. Close our project. Delete binaries. Derive data cache intermediate. Save it. And rebuild our project. Now our project has rebuilt, and let's check our directories hierarchy. And here we are. We have a new module with a new module actor here. Rebuild.
What you waiting for?
Whatever your goals, let's get started. Tomorrow begins today with NatWest.
Oh.
Hey guys, Sneaky Kitty Game Dev here, and in this video we're going to be covering modules. So just to begin here, I'm on just a blank form of actual Claymore module. And this module has my actual Claymore code inside of it. You really kind of want to set up features to where they are independent from other stuff. So for example, a door, you would want that to be contained inside of its own little space, so to speak, just like the Claymore. So, what better way to, I guess, show you how to use a module than, let's call it n.cpp tutorial. We want to scrap that and replace core module and default module implementation. So we're good to go using. So we're going to go ahead, which again is going to be custom door. Our random tutorial has the 3 files. Well,
So I wonder if maybe you can't put these. It must be that you can reference stuff from the game. Unreal Engine module reuse main game code. Unreal and oh, I did already. Unreal Engine dependent modules. Difference between public and private dependencies is that they are visible to public and or private code respectively. Thus, public is used, functionality can be exposed to other editors or plugins that depend on your game or module. If you'd like to learn more about... So if I add a module to the public dependency module, does that mean that my plugin can access files in both its public and private folders, or does it mean that its public code is visible to required by your public source files? Module rules class, you can find the following. And where can we find a list of key names? So much helpful. Two Unreal Engine modules dependent access Unreal Engine. I tell you what, let's use ChatGPT here. Maybe that'll help. Let me just do this offline for a second. ChatGPT. Let's see if we can get some answers from ChatGPT. Right, let's try this. How how do you make an Unreal Engine module have access to the main game module? But I have done that. Damn it. I have done that. So just to test it, I've gone into Science Test Build. I am dependent on Science, and that is the module name. Science, yep. And if I open up this is called Science. I wonder if I can do that. Hmm. But my you can include the necessary header files in your module's source files and use the function as needed. I guess also, like, let me just be clear about this. So if I just do that, is that gonna break anything? No. So it can see that stuff. There's something wrong with my element factory. So this has all been fine. Oh, that's so annoying. Fatal error. Okay, so let's do the other ones. Let's make shareable, and then this will be I element factory. Nope. Make share make shareable, but that needs to be a T shared ref like that, I think. How about that? Right. How about that? No. I thought it worth a try. It says the test cannot get create element, but create element is definitely defined. We know that because we can see it in here. It's defined not only is it defined in factories here. Oh, hang on. Let's just make sure we're not doing anything like that. Yeah. Oh God, can you imagine? Let's actually also just take this. Oh, that's interesting. I wonder if the struct needs. Surely not. The struct surely doesn't need a CPP file, right? That's the interface. It's got nothing in it. Cool. That's the interface. That's the header. It's got nothing in it. Um, Maybe it doesn't like that. Return null pointer. Oh, that's interesting. Still the same thing. One unresolved external. Yeah, I worry. Element factory. Element factory. Element factory. This one is... Now this is saying an unresolved external symbol I element factory. What was that again? This is making me a bit sick now. What is this? Let's ask GPT what that is. What does do? To make a type known to the reflection system that can be used with various engine features such as the type with the reflection system, by adding it to the... I wonder if I need to do that for this then. So if I do... hang on. Do I also need to add this in here? I wonder. Like, just like that. I'm gonna do that for this as well, I think. Like so. Okay, wasn't that? dependency modules. So in this, there are dependency modules, and I'm dependent on the science. Mm, it does. And I mean, it is public. Um, I wonder if I were to do an actor and then actually try and access one of its properties instead. So I think if I close all this crap, 6 hours, jeez. Oh, I'll go to bed soon. If I do this instead, like that, new object, a element, actor, like that, and then I do element, set neutron count, nucleus, like that. I wonder if that gets a bit confused. No, it's fine. Yeah, it's just something wrong with my factory, man. My element factory has got a create element on it, and it doesn't like it. Maybe, is it that I have to, ah, is that what that is? Hang on, if it's like this, do I need to implement it here? I bet I do. this would not go here instead? I wonder, I don't know. Element redefinition, let's get rid of that. That was it. So, pure virtual function must be in header. Can you define pure virtual function in CPP? Hmm. So it should be okay, right? It should be okay. I wonder, instead of that being a problem then, do I just need to do that? No, because it becomes abstract, I see. So this is definitely the case where, like that. Yeah. So why that element factory dot h element factory dot cpp? Yeah, I don't know. Element factory dot h factory dot cpp. Who knows? Well, considering I've got this working now, let's just see what actually happens. So confused about that. So confused. So now I've got to remember how to do this. It's session front end, uh, automation, um, let's see, science, or element, factory tests, start tests. Cool. I'm guessing if I do that again, yeah, it runs it there. Returns a new object, and then, oh, does it not actually get here then? I guess it does, it's just not. It's too optimized probably. Pragma, optimize, off, on. Try it one more time. Optimize, yeah. Time to go to bed now, I think. Oh, what a nightmare. I don't know if that's right, because I just don't feel like you need to declare the virtual inside the header file. But maybe because it's trying to look for it, and it's just like, I don't have anything, because it's declared in the CPP file, and I can't see that whilst I'm running in compiler. So that might be the problem there. Let's see. Element. Factories, I see. Factories. Yeah, there you go. So element is something, and so it's not null. Oh, that's that. Goodness me. I think I'll call it there. Thanks for whoever watches this in the future, and keep loving, keep learning. Bye.